All right, we are live.
All right. So, who's gonna kind of lead this discussion today?
I can do it since
Jason's behind the
probably
wheel.
Jason's turn, but I'll do it for Jason.
Alrighty.
So cool. You have any questions of the prep assignment?
Um, I didn't think it was too difficult. I mean, um, I think for me, I'm just memorizing that whole process to find the standard deviation, like all those steps, and that's pretty much it. I mean, but I think everything's pretty clear.
There's a lot of steps.
Yeah, there's a lot of steps, and if you don't kind of practice it, it's kind of hard to remember, at least for me anyway.
Yeah.
So
The videos were pretty helpful, the tutorial videos.
yeah,
But
I think so too.
Yeah. I usually go and watch those first and then do the reading so that it all makes sense.
Yeah. Um, I don't know. Oh, go on.
I was just gonna say one thing that stood out to me that I was kind of confused with at first, but I thought about it and I was like, that makes sense. Like with the four-sided die, right? When we numbered the events, like I thought it was kind of weird because when you find the whole standard deviation, right, you multiply the event by the probability of the event.
I think that's a weird step too. Like, if it's the same reason you're thinking, like, why does the actual event number? How does that affect it? It just seems so bizarre to me.
Yeah, and kind of what dawned on me is that really what you have to define what your event is, right? And so he didn't really in that question necessarily give, or whoever wrote it, but he didn't give like what the event really was. He just said he assumed that it was like weighted. So an event of getting four means that I don't know, like because I was thinking kind of the way I assumed that it was that it's like what's the probability that you'll get a four, right? Given however many rolls. Well, then it's always just going to be one over however many rolls, or you know, that might be wrong. But anyway, it dawned on me that it matters what you're actually choosing as your event. And so in that case, he was actually choosing the weight of the side of the die as the event. And
Wow.
so
right.
it wasn't just finding. Uh, um, I guess that's what it seemed like to me. And that made sense because then that number actually means something. Otherwise, you're just counting, and it doesn't actually mean anything to multiply it. So.
Yeah. Um, Also, I think it was that same dice example or whatever. Like, why can't you just add up the numbers and divide by, the traditional way of finding the mean? Why can't you do 1 plus 2 plus 3 and then that's 6 divided by 3? The average is 2. Like, why so many steps? Does it?
One thing that this does allow us to do though is like if you have an uneven distribution of probabilities, that's assuming that it's like exactly the same probability for every event, right?
Everyone, right?
So that might work, but then if we said that like for example, getting a four for some reason is more likely than all of the other ones, then that wouldn't work because you have to weight the four to be a higher probability than the others.
Got it. Yeah,
So
yeah.
it allows us to actually weight it based on probability instead of just saying, they're all equally as likely.
So maybe for those more basic probability things like a dice or flipping a coin or something, it's the exact same odds, but maybe down the road there's stuff that's more.
Exactly. So like the example they had in the textbook was the flipping the heads or tails.
Yeah.
You're going to get heads at least once, twice as often as you would get it not at all or both of them be heads. There's like three outcomes with that. And so the
Yeah.
middle twice as likely. So then you have to weight that one higher. How to do that is really to make them all equally as likely.
Gotcha. Um, oh,
That's a good
one,
point
one,
there.
one question I did have was it was in one of the videos. I think at the very end, the guy who's talking is like, "Oh, you guys could pull up this from iLearn. It's in the Excel thing, and it finds the mean. I think standard deviation and variance. It's not with the graphs, but he says that we could get it, but I can't find it anywhere. I can't find it, and I emailed the teacher, and he sent me the link to like the other stuff we've used, but I couldn't find this particular one. So I don't
Yeah,
know.
I didn't try to find it yet.
Yeah.
I'll
Maybe
try to
it's one of
find
those.
it.
Yeah, it could be one of those online things that they did have, but since it's always changing, they got rid of it, or I don't know.
Yeah, it might be it. Oh. What's is it Brother Bennett? Is that our teacher? I should remember.
What's that, Bennett? Yeah.
He'll probably see this video and maybe he'll respond.
I know, right? I know.
Hi, Brother Bennett. Anyway. Cool. You guys want to try doing the quiz?
Yeah. Let's give that a try. Let me pull that up.
I'll be at home in like 2 minutes, and then I can jump on and do the quiz with you guys too. So, if you guys want to just start, I'll pick up where you guys left off, and then I can at least just go back and fill in the answers to those. That way we can do it together.
Yeah, that's fine with me. Bryce, are you still there?
Yeah, I am. Can you hear me?
Oh, yeah. Okay. I saw your picture and it just kind of froze, so I thought we might have lost you or something.
I was just being quiet. Not moving.
Okay, so week 2, lesson 4, group meeting, right?
Yep.
Okay. Let's see. Okay. Do you want me to read the questions?
Sure, if you want to, that'd be good.
Okay. So, question 3.
We can skip
Yes,
first two.
skip 1 and 2, right? So, number 3 says, no, give all your probability answers as decimals. For example, point, blah, blah, blah. Not as percentages. So it says human blood can be classified into one of our basic types, O, A, B, and AB. The proportion of people in the population of the U.S. with each of these blood types is summarized in the following table. Then it says use the data to answer the following question. So, for example, for type O, it looks like 45% of the population has that type, and then 40 for A, 11 for B, and AB is 4. And then true or false, the blood types of the proportions given in the table above define a probability distribution. So I think to find that out, it needs to add up to 1, right? If it's a...
Yeah.
Okay, so let's see. So 85...
85 plus 11 plus 4, yeah, that's 100.
That's 100. Okay, so true.
True.
You get true? Okay. And then number 4, what is the probability that a randomly selected person in the United States has type O blood? Round to 2 decimal places. Okay. So, I mean, that one's pretty straightforward. It's 0.45, right? Since it's out of 100.
O is 45, right?
Yeah. So
it'll be 0.5?
Or I think it's just 0.45 because it says round to 2 decimal.
Okay, yeah.
Okay.
Yeah.
So that one was pretty easy. And then 5.
True on 3. Sorry, it kind of cut out for me.
Oh yeah, true for 3. Yeah.
Okay.
And then 0.45 for 4.
Okay, got it.
And then 5 is what is the probability that a randomly selected person will not have type O blood? Okay, so it's 0.55, right? 0.55.
that will not have O?
Yeah, will not. So it's just 1 minus 0.45. So 0.55.
Yeah, 0.55.
So far, I'm liking this quiz. It's going pretty well.
So far, so good. No commas.
I know.
I know, right? Comma 0.55. Okay, so it says Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. Wow. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following question. Okay, so if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to 3 decimal places. So what? It sounded like there were 7, or were there 6? Yeah, 7.
7.
Oh, it's bowls. I said bowels. So 7 bowls containing
A
urine.
little less gruesome.
Yeah, I was like, that threw me off. And so only 1 out of those 7 actually has the cancer, right? So let's see what that comes out to.
Well, I got 0.143.
What's that? You got what?
0.143.
Yeah, that's what I got too.
It says round to 3 decimals.
Yeah. So 0.143. Okay. And then number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dogs would do this well by random chance alone. Which of the following statements is most appropriate? So it's the first one, right? This provides strong evidence that dogs can detect bladder cancer. Since they're saying it's unlikely it happened by chance.
Yeah. Since they say that it's very unlikely the dogs would do it by random chance alone. That's kind of the weird part, too, because they were saying, you know, what is a high probability or a low probability? I feel like it completely depends on what you're talking about.
Yeah, it's true. Okay, so
That seems good. That it is good.
Okay, so the next one is M&Ms are small chocolate candies. Okay, good to know. The M&M's website previously indicated that in the U.S., the distribution of the colors in a bag of plain M&Ms is given in the following table. Okay, I'll skip that. It says, if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy? So round it to 2 decimal places. So red is 13%, so 0.13, right? Or does that add up to 1? Let's see.
Yeah, they don't give us green,
Well,
so
they
it
don't
doesn't
give
add
you
up to
green,
1 because
so-
they're going to ask.
20, 30, 44, 58. So that's 84. So green would have to be 14.14.
Hold up. What? So for 8, did we get 0.13 for 8?
Yeah, I mean, it'd be,
Just what it says, right?
yeah, it would be what it says,
Oh.
0.13.
Okay. And then what did you say for green?
Well, if you add them all up, so that's 20, that's 40, 44, 58,
So 0.16.
71 plus 13, it'd be 84. So green would have to be 0.16.
Yeah, I think you're right. Okay.
Okay, good. Sorry, it dropped out again.
Oh,
Okay.
sorry. I know my phone keeps falling. This is ridiculous. So I'm trying to put it up and do this at the same time. So
So for number 9, you got 0.6.
9 is 0.16. So 0.16.
Yeah.
And then, so 10. What is the probability that a randomly selected candy is not green? So that's 0.84, right?
0.84. Yeah.
Yep.
All right. So the ACT scores of students admitted to a medium-sized public university in the Western United States was taken from CAPEX.com. The following summary statistics were calculated. Okay, so half of the observations are less than or equal to what number? Oh, right. So we look at the median, right?
I think so.
I think so. I think it'd be 24. Right? Because the median is found by listing them from smallest to largest.
4.3 all the way up to 35.
Yeah. And then it's the one directly in the center, so half or less than or equal to. Yeah, I think it's 24, right?
Yeah, I think it's 24. I'm gonna go see if I can find a better spot with Wi-Fi.
Okay.
I don't know. Actually, there's a thing right above me, so it should be working.
Almost done.
Okay, so number 12. Based on the info on the table above, the top 25 of the 25% of the students scored above what number? So that'd be the third quartile, or 27, right?
7. Yeah. Okay.
Okay.
So that'd be 27?
I think so, because I think the third quartile is the 75% percentile.
Oh, yeah. Okay.
I think. Okay, so 13 is, which of the following statements is not one of the 3 rules of probability? Okay, the first one I think is...
Yeah, that first one definitely is. It's 1 minus the probability.
yeah.
The sum of the probability in any...
The last one, if the probability is high, then the probability is positive. If the probability is low, then the probability is negative.
Wait, so,
Yeah,
so,
that's not true.
so we're saying that a choice number 3?
Well, yeah, because think about it. A probability, in the video they said that the probability is anywhere from 0 to 1. Which
So that
makes
one's
sense
good.
Because in a die, if there's 4 sides, it'd be 0.25, and there'd be 4 sides, right? Or I guess in a die, it'd be 6 sides. So anywhere from 0 to 1, that's true. That's
Okay.
accurate. So that's the last one's right. The first one is the outcome will not occur is 1 minus the probability that it will not occur. So it'd be the same if it would occur. So
Okay. So
that one's right.
We're looking at if the probability is high, then the probability is positive. So that one's wrong, right?
Yeah.
I think so. I think that's the wrong one.
Okay, cool. So did you get caught up on the first ones we did?
Yeah, you know what? I obviously 1 and 2.
Right.
Number 3 is true.
True. And
Number
then
4 is 0.45.
Yep.
Number 5 is 0.55.
Yep.
Number 6 is what was 6?
0.143, I think. Yeah.
0.143. Okay, and then number 7.
This provides strong evidence that the dogs can detect bladder cancer.
Okay. And then I got
plenty of points.
What's
All right.
that? We're good to submit?
Plenty of points.
All right. Let's see.
I don't know. Hopefully that's right.
All right. 1, 2, 3.
100. Nice. There we go.
There it is.
Oh man.
There it is.
Man. Ever
Nice.
since Desiree stopped coming, we got 100%. No.
That's jacked up. Is she not in our group?
No, apparently she dropped the class, so I guess she changed her major.
All right.
So.
How'd you guys do on the homework?
I
I haven't done it yet.
I think I did this one already. Yeah, I got an A on it. It wasn't too bad. Yeah.
Was
Not
it like
too bad.
this?
Yeah, same sort of stuff.
Okay, cool.
Yeah.
I like it. Good.
Awesome. All right, so until Thursday, right?
Yeah, Thursday 5.
All right, guys.
Thanks
for
guys.
coming.
See ya.
Yeah, thank you.